transport of glucose into the cells. Right? What's the glucose going to be used for in the cell?
It's mitochondria for cellular.
Yeah, cell respiration. But where is it going to start? The glucose is going to start metabolism in the cytoplasm. Glycolysis. The first thing that's going to happen is it's going to be phosphorylated in form of glucose 6-phosphate. So that's what we're doing here. We're trying to get glucose into the cells. We know that glucose cannot be transported diffusing through the phospholipid bilayer. It's a facilitated diffusion process. Right now, clearly, we have a higher concentration of glucose in our blood than we do in our cells. Okay? And this would be metabolized very quickly. This would be phosphorylated, and that no longer is glucose, so our concentration of glucose is still low inside. Okay? High concentration of low. So the first thing that happens is that the pancreas is going to respond to this high glucose concentration. And the glucose is going to fit in to the glucose receptor. That is going to set in motion some really, really cool things. The pancreas, and I'm going to just leave the glucose there to say glucose receptor interaction, and then there's going to be a response here. Obviously this DNA would be in a nucleus, but that's not what I want to focus on in this part, but the DNA is involved. Because a message, after this interaction happens between a glucose and a glucose receptor, at the pancreas level happens, genes get turned on. And the genes that get turned on are going to be genes that make protein. So we've got our DNA to our ribosome connection. And what protein are they going to make? They're going to make insulin. You could model in detail that whole gene to making a protein thing. Protein synthesis, transcription, translation, all that kind of stuff that goes in there. So you have wonderful pieces of this big puzzle. So the pancreas begins producing insulin. In the pancreas, yes, this is all in the pancreas. What cells though? I want you to know specific ones. Beta cells. Gotta figure that out. The insulin is then transported. And this could be an exocytosis that's happening, but for us, we'll say it's transported, and that would be requiring some energy. The insulin is transported into our bloodstream. Nope. Insulin is going to travel in the bloodstream. And it's going to fit into receptors. What receptors is it going to fit in? I saw this happening quite a bit out there when you were trying your models for part of it. Yeah, it's going to fit into insulin receptors. So let's go to the muscle. So the insulin fits into the insulin receptor. And this is going to set in motion something really cool. You'll notice that this does not have a glucose transporter in. Glucose cannot get in. This will set in motion, and I'm not going into detail in here. Trust me. There's a communication that goes on here that then causes this vesicle to move to this region of the phospholipid bilayer, and the glucose transporters are placed into the cell membrane. Glucose can now start, through facilitated diffusion, moving into the cell. Does it need to get into the vesicle? No. It just needs to get into the cytoplasm, because now we're going to go into glycolysis. Okay, so now glucose can freely move in, and if, in this case, you don't need the glucose right away for cell respiration, i.e. you're not exerting a lot of ATP, it will go into storage in the form of glycogen. We got our muscle cells. The pancreas itself has this system. Okay, I'm not gonna show it in the pancreas, it's a little bit congested, but I can show you in the adipose cells how that works. So insulin fits into the receptor. The vesicle moves to that cell membrane. The glucose transporters are placed into the cell membrane. They just have glucose transporters. Why? Doesn't? What is, I told you what is the organ that uses the most glucose?